Hi everyone, this is Mr. Richmond, and for this video we're going to be looking at the different types of variables when conducting a scientific experiment. Throughout this video I'm going to be going over multiple examples, one of which is going to be from your Google Doc assignment. Feel free to pause the video and try some of these examples on your own if you want some additional practice. So I'm pulling these notes straight off your PowerPoint presentation from online, and just a few definitions for some vocab terms that we're going to be working with. A variable is any part of an experiment that changes during a scientific test. The independent variable is something the experimenter is manipulating or intentionally changing to see if it's going to have an impact on what they are testing for. The dependent variable is what is being measured in response to the independent variable. And finally, a controlled variable or any factor that is held the same or constant throughout the experiment. This should be everything but the independent variable. So any factor that you can think of that needs to be held the same. And then finally, I've got an example for you from your PowerPoint notes as well. You've got a scientist deciding to test whether a type of fertilizer makes a flower grow faster. What are the independent variables? The independent variable is going to be the type of plant fertilizer. How are we going to measure that, or what is going to respond to the independent variable? That's going to be the height of the plant. And then things that are held the same, controlled variables, the amount of sunlight and the water the plant receives, the amount of soil the plant is grown in, and using the same type of plant. You can't have a sunflower compared to a cactus. That would not be conclusive data. So I've got a couple more examples I want to go over with you for this video. Again, feel free to pause it to practice on your own. Let's say that I've bought a new type of grass seed for my lawn, and I've got two different plots of my lawn. And let's say that plot 1, I am not applying the grass seed. Plot 2, however, I am. So plot 2 is getting the grass seed. What are my variables for this experiment? How am I going to see if this grass seed is going to be working or not? Well, my independent variable was being manipulated is going to be the grass seed. How am I going to measure that? I could do that a couple different ways. I could measure the length of each grass blade in plot 1 or plot 2. That might take me all day, but I could look at the color of the grass. It might be a little bit more green if it's working effectively. So color of the grass, length of grass. That's how I'm going to measure it. Control group, that's a term that we haven't talked about yet from your PowerPoint notes. This is the comparison between the two plots that is not exposed to the independent variable. It's status quo, it's business as usual, as I usually tell my students. So in this example, the control group is going to be plot 1 of land. Controlled variables, everything should be held the same except for the exposure of grass seed. So that's similar to our flower example from our PowerPoint notes. So the amount of sunlight that the grass is getting, the amount of water, I'm going to say amount of water, amount of sunlight, the humidity level could have an impact. When the lawn is being mowed, I can't mow plot 1 on one day, then plot 2 the other day. That's going to probably yield some ineffective results. And really anything else that you can think of. The type of grass, and there's probably a few more. So having 3 or 4 examples would be good enough. So I've got experiment number 2 for us to work through. And let's say that I'm changing the angle of this ramp and seeing how far this ball is going to roll. I want to see if the angle of the ramp has any impact on the length that the ball is going to travel. So the independent variable, what I am changing, is going to be the ramp angle or ramp height. How am I going to measure that? Well, the distance that that ball is going to travel. Control group may not always be applicable, and I could argue that it's not really applicable here because every single trial is going to be exposed to a ramp angle. So we don't have anything in our similar to our first experiment where it's not exposed to the independent variable. So control group, you could say NA, not applicable, or if you really wanted to, I guess you could say that you did do a trial with no ramp angle. That could be considered a control group, but NA would also be applicable here. That would work. Controlled variables, things that are held the same, I would say the type of ball, the mass specifically could impact it. The surface of the ramp, you don't want to be changing out the ramp. Surface of the floor. Where you are measuring your starting and ending points. So for example, you don't want to be measuring for one trial at the end of your ramp, then for the next trial at the beginning, or the start of the ball, end of the ball. So make sure that you are consistent with that as well. So that's a third example for you. The last example I want to go over, and if you feel like you've had enough practice, that's perfectly okay, but I'm going to give you some answers for your Google Doc worksheet. So your Google Doc's going to look like this, identifying variables. Make sure that you click on File, Make Copy. And then we've got a similar experiment where a control group is going to be applicable. You've got one group getting some penicillin. We are testing to see if penicillin is going to prevent infection. And then we have a hypothesis or a prediction in an if-then statement. If penicillin is added to bacteria, then the medicine will prevent the growth of bacteria that causes the infection. You've got Leo placing 2 circles of paper in a petri dish. That's something used for growing bacteria if you want to imagine 2 circles. One circle has penicillin, the other does not. You pour the liquid with bacteria into one petri dish. Both circles of paper are placed in the petri dish about 3 centimeters apart, so it looks like he's doing something to keep some variables constant. At the end of the experiment, a circle with a radius of 2 centimeters formed around the circle soaked in penicillin. There was no bacteria growing in a 2 centimeter circle. No change had occurred around the circle of paper. The bacteria were growing well. So what was the independent variable? Well, the penicillin. So I'm going to go ahead and plug that. I want to see if that is going to prevent infection. What's the dependent variable? Bacteria growth. What's a control group? So you had 2 different circles. One circle had the penicillin, one circle did not. So the business as usual, status quo, that circle with no penicillin, not exposed to the independent variable. And there's probably quite a few different constants or controlled variables. If you could name 2 or 3, that would be fine. But any conditions that those petri dishes would be exposed to, so humidity levels, you never know, could impact it. So humidity, the amount of time that the penicillin is exposed to the petri dish. I'm going to say amount of time. Maybe light exposure. You can't have one dish in a dark room, one in a nicely lit room, so light exposure, and you could probably think of a couple more. So that's another example for you, and you're going to do the remainder, these 3 examples or experiments on your own, and this is what you're going to be handing in as your formative grade. I hope this video helped you. Good luck with the assignment.